How's it going, everybody? And welcome back to our Cisco Enterprise series. In this video, we're going to continue our OSPF conversation by talking about troubleshooting adjacencies. Now, there's a lot that can be done when it comes to screwing up how you configure OSPF. Some of it can be self-induced. Some of it can be just not being aware of what's going on environmentally. So we're going to talk through a couple of things that you need to be aware of in terms of just normal high-level stuff. I'm not actually going to go through and specifically break OSPF per se. That'll come EIGRP, BGP, OSPF, multicast, DMBPM. We're going to be troubleshooting that stuff down the road. So where I'll be injecting faults, and then I'll be walking you guys through scenarios and how to identify them for those of you that are looking to see what that looks like. Unfortunately, the new CCIE lab exam, which would be specific to that, or like the NRC series, the NRC exam, there's not a dedicated troubleshooting section to the CCIE lab anymore, where that would be really beneficial. I spent a lot of time troubleshooting all the routing protocols so that I would know how they worked behind the scenes, and having a dedicating time to just breaking it and seeing what is broken, what it looks like when it's broken versus what it looks like when it's working, looking at debugs and show commands and stuff like that. That's extremely beneficial, especially then you can spot things then normally other people won't. So that's what I refer to as my TAC training, the Technical Assistance Center training. At the time, I was pretending like I was on TAC, and I'd go through and just break the crap out of networks and fix them. But that's how you get good at stuff, right? You identify problems quicker. So we're going to take a look at troubleshooting adjacencies and exactly some high-level details as to what you could do to help identify what they are. So where can problems arise? Well, transport problems, connectivity in between two devices, and attribute negotiation problems. Do you have, for example, one side has the network type of point to point, and the other one's got it as broadcast, or do you have a MTU issue, or do you have a authentication type mismatch? Type 1 clear text versus type 2 hash password. So there's a number of different things that where you might have a stub scenario where one side is configured to be a stub, the other side is not. So a stub flag is set where it shouldn't be. So these are going to be things that you're going to want to take into consideration when you're looking at how the routing works. So that'll be one of the things that we'll definitely be taking a look at down the road. But right now, we're just really getting started with OSPF, so we want to just understand where would you want to start looking. And again, we'll look through scenarios where we'll break things intentionally and walk through how to fix them. So useful troubleshooting commands: show IP OSPF neighbors, show IP OSPF database, debug IP OSPF adjacency, and debug IP packet. So these are just going to give you some normal outputs. One thing that I definitely recommend everybody does is they go through and they are familiar with normal operation first and foremost. Know what it looks like when it's working correctly. And then when you know what it looks like when it's working correctly, then do something to try to break it. Whether it is whatever fault you want to inject. And then with a handful of debugs running and stuff like that, you'll be able to start seeing good versus bad. And I can tell you one thing from personal experience. My first and second time at the CCIE lab, I passed all three sections. Now, back then it was troubleshoot, diagnostic, and config. When I was in the third attempt, the second attempt I passed all three sections. I just didn't pass the overall. So I missed a lot of, and I want to get into specifically how they calculated it, but I remember specifically sitting in my third attempt at the lab and sitting in RTP, North Carolina, and I was troubleshooting an OSPF adjacency issue. And was it EIGRP? I think it was OSPF. There was an OSPF and EIGRP issue that I had to go fix. Well, as I was going through and reviewing what was going on, it wasn't obvious at first. And it wasn't until I actually threw a debug on to see what was going on. Because here's the thing. you can catch a lot of things out of the gate if you know what to look for. Like if you do a show run pipe section OSPF, and you can just do a quick run through of the config that's there. And if you have two different devices that are supposed to be forming an adjacency but they're not, or it's flapping, or you got some squawk going on, you get an alert going off. If you just do a quick comparison between the two routers, you can quickly identify which one's doing something. But here's the thing. You're in the troubleshooting section of the exam where you know something's going to be broken. You just don't know exactly what's broken. But here's the interesting thing. There is going to be a lot of times outside of the lab where you're going to be in a real world scenario where something is not working correctly, where it should be, and you're going to have to be the guy or gal that's going to have to put your troubleshooting hat on and go through and go, okay, what is needed for this particular thing to work? So you'll have to start looking at outputs. You'll have to start looking at the database, the neighbors, the interfaces. You'll have to start looking at everything. And I will start on the box itself and I'll work my way out from there. And I'll explain what I mean by that about looking out, you look at the neighbor. What does the neighbor connectivity look like? What does the database connectivity look like? Is there a discrepancy between the two? Stuff like that. You're looking for mismatches in what you know is to be true. So if you're seeing a false positive, meaning, well, I should say a true positive, or whatever they refer to it in the security world, if you identify an issue, that is what your goal is to try to identify first. If you can identify the problem, therefore, you should be able to pretty easily fix it. One of some of the best words of advice I had ever heard was actually from a jiu-jitsu instructor that says a problem that's well understood is already half solved. Because you already know the problem. All you have to do is map a solution to the problem, and boom, you're in good shape. So I still live by that because it's very, very, very true in this world. So I'll give you a classic example because we're talking troubleshooting. I'll give you a real world example. Probably 3 months ago, something like that. It was an EIGRP issue, but still it goes back to the point of troubleshooting. The issue was where I had a upstream router that I had no access to, and then I had a downstream device that I had access to. So I was logged into the downstream device, and that's all I could access. So I was looking at this piece of equipment, and I'm sitting there watching the outputs go off, and I'm like, the EIGRP adjacency would come on, then it would go off, then it would go on, then it would go off. I'm like, what is going on here? And so I did a show IP EIGRP neighbors, and I noticed the round trip timeout was set to 5,000. I was like, and at every 3 minutes or so, not quite, EIGRP would flap. And I was like, what is going on here? So I'm like, okay, something's clearly not right. What do I got to do to fix this? So, and it was causing routing flaps. So as I was digging into it, I was like, oh, wait a minute. I don't know, I'd already been on a call at this point here I had been working on this particular site for I think 4 or 5 hours at this point. So I'd already spent more than half a day working on this particular site, and I was only part of the way done. We still had a lot more to troubleshoot. So eventually, when we were digging into it, so my work computer sits to the 90 degrees to my right. So I was on that computer. I swung over to my personal computer, and I Googled, what does this mean? Because I couldn't remember, especially when you're tired and I was under the gun because things weren't working. So my goal at that point was to go through and figure out how to solve the problem. So I Googled the problem, and I was reading through. I was like, IPMTU. Oh, okay. So then what did I do then? I went back to my work computer, and I did a quick debug of EIGRP. And as I was looking through it, I was able to identify, oh, okay. And I said, can you do me a favor? So I just wanted to verify both sides. I did a show interface, and my side was set for 9,000 for the IPMTU because that's what the new Catalyst 9Ks are set to. Well, I said, hey, can you verify the ASR? Can you verify that's MTU? And he looked at it, he goes, it's set to 1,500. There's our problem. So I made a quick change, and then EIGRP stabilized. I saved that config, and then we continued moving forward. So we were just we were putting out one fire at a time, even though I was remote, and then there was like 4 people in a conference room on a bridge. They had used as like one of those those tabletop conference room phones to call me. So they were going through this process of there were like 3 or 4 other issues. I said, okay, one at a time. Let's just firefight. You can't put out multiple fires at the exact same time with one person. I was like, I need to focus on one thing at a time, and I was like, I'll troubleshoot them. And a couple of additional issues came up, but they all stemmed back. Once I heard all 3 of them, I was like, that's switch related. So eventually I told the customer, I said, I'm not going to be, I don't know what to do to fix that off the top of my head. So, but to me, it shouldn't be doing that because, long story short, they were deploying the same exact equipment in this location as they had done in several other locations that I had already worked on. So the configuration that we were putting into play was a well-known good config. So why we were having issues in this particular site was throwing us all for a loop. So I was like, okay. So I said, do these switches have support? He said, they do. I said, okay, go ahead and call TAC, tell them you got to set one network down. And I was like, we need to get an engineer on the phone as quickly as we can to try to isolate the problem. And he's just like, and when the collective, I was like, oh, okay. So everybody at that point shut up. And the engineer for that company decided, they got on the phone, they went through, gave TAC the information. We had an engineer in like 15 minutes, and he started looking at stuff. And within a very short period of time, TAC was able to find the problem. So fortunately, it does work out that way sometimes. But the bottom line here is, even if you've gone through all this, I'm going to do over here because my screen isn't very wide for my video camera. Even if you've gone through all of this and you know how to troubleshoot the protocol itself, there are going to be things that no matter how many certifications you've got or how many years of experience are under your belt, there are going to be things that are going to be outside of your control or what you know. So that is when you have to humble yourself. In this case here, for me, it was like 1 o'clock in the morning, and I have been basically working on this particular site since like I think 5 o'clock is when we got the all clear to go ahead and begin doing the changeover. We were swapping out a bunch of switches that day. So you have to take into consideration that you've already been going several hours at this particular situation, and it's like, okay, it's time to time out. Let's bring in more help, and you do what you got to do. So that the whole point of that was, no matter how good you have this information right here dialed in, and how good you are at troubleshooting the protocol, sometimes it's could be completely something else, and it's outside of your wheelhouse. I would never consider myself to be a security engineer. So when we run into problems like that, it's like, okay, time out. Let's go make sure. Let's get Cisco on the phone, or let's call the vendor, and get an extra set of eyes, or reach out for help, stuff like that. Because you never want to be, you never want to take on the full responsibility yourself, because especially if you have a team to back you up, you want to like, hey, I'm having a problem here. Can you help me out? So let's talk a little about the normal OSPF adjacency state machine, so we can understand what exactly is necessary. So down all network types except for non-broadcast. Attempt is only non-broadcast, and we won't really be taking a look at a transport that is only non-broadcast, meaning unicast only. So you can basically forget about attempt. So there are going to be situations where you might see some legacy circuits out there that don't support multicast. Frame relay, if they turned off if they don't have the broadcast capability turned on in frame relay, then you'll be doing neighbor commands anyway. But it's when you do unicast for OSPF with the neighbor command or EIGRP with the neighbor command, you're essentially configuring it like you would BGP. So if you understand BGP, which at this part of the series we haven't gotten to BGP yet, But in the way that I'm recording the videos, I've already covered a lot of BGP. But when you get to the BGP section, which would be further on down in the playlist, you'll see what that looks like. So it's just a neighbor and an IP address, but with the configuration wise, it looks similar to BGP for both OSPF and EIG. RIP does it too, but those are just some of the cases that I wanted to point out. So we're not going to be dealing with the temp at all. So it's going to be strictly broadcast only capable interfaces, medias, meaning multicast is supported. Init is a transport issue. So hello is sent, but neighbor hasn't responded to it. This could be a number of different things. So typically speaking, this could be a, for example, I'm thinking for the moment here, you could have the port in the wrong VLAN by accident. I mean, that's kind of an egregious misconfiguration. And what do I mean by that? Is let's say you've got a couple of routers that are connecting into a single switch, and those particular ports are supposed to be in their own dedicated VLAN, and you haven't put that port in that VLAN yet. So you sent a hello, but neighbor hasn't responded. So you sent it out, but it can't find its way back. Stuff like that. So just make sure that your layer, it goes back to a comment that I made a while back. I forget what video I said it in. That make sure that layer 2 needs to be rock solid before you can move on to layer 3. And this is layer 3. So make sure your layer 2 is rock solid. You're going to see this, especially if you're going to go after the lab exam. You're going to want to make sure that your layer 2, your VLANs, and your trunking, and if you had to do any port channeling and stuff like that, you're going to want to make sure that stuff is locked in, rock solid, and you can troubleshoot the ever-living snot out of layer 2. So that you can definitely make sure that everything's squared away. Because if it's not, then you're going to run into issues like this where you send a hello out, but nothing's coming back in because, oops-a-daisy, you accidentally, or maybe it's configuration-wise, you didn't check to see if the other port was in the same VLAN as yours. Or, if it's a trunk link, is that VLAN allowed to cross the trunk? And stuff like that. Two-way, stop here for DR others. So, remember what I mentioned, you're going to have, you can form a neighbor but not a full adjacency, right? So if you don't get to this state, there is an issue with transport. Multicast could be blocked, OSPF could be blocked. So DR other essentially is you and I can both see each other, but there could be a multicast issue, or there could be an ACL that's blocking the response of OSPF. And so we'll be able to test two-way. Like you can literally create an ACL that will block outgoing connectivity. So stuff like that. I'm going to attempt to test this stuff out, but these are just some of the capabilities that you would want to know about. Xstart, the database descriptor packets begin. These three you really can't do a whole lot with, right? You're exchanging the OSPF database. Either you're allowing it or you're not. Duplicate router ID. Two routers with the same router ID. So if you see this, then you potentially could run into what they call a flood war, where when the correct router sends an update to the router with an incorrect router ID, the incorrect router ID believes it has old info and ages it out. The advertising router is the node and the LSA ID is the link. So just one of those things to keep in the back of your mind is make sure that every one of your routers in your OSPF domain, regardless of how many process IDs and regardless of how many areas, that everybody has their own unique router ID. So some of the different attribute issues that you might run into. Broadcast and NBA MA, non-broadcast multi-access, will use DR-BDR. So non-broadcast multi-access and broadcast. So when you see this term, right, broadcast and NBMA, non-broadcast multi-access, this is going to be frame relay. So multi-access means two or more connections available out this interface. So let me give you a really quick drawing of what that means. So broadcast and non-broadcast multi-access. If I have R1, I have R2, R3, and I have R4, and then I have a link. They all connect into the same switch. We're all in the same VLAN, maybe spanning multiple switches inside of a stack, something like that. Well, if I have gig 1 here, that's gig 1. I have gig 1, gig 1, and I say I got gig 1, right? Well, regardless of what you do, you're able to reach out to multiple devices on regardless of where you're going. So you're able to go here, here, and here, there, and there. So if that's the case, then it's multi-access, meaning you can reach more than one endpoint on a particular link. So this is going to be a type 2 LSA. It's going to be the DR LSA, is what they commonly refer to it, or is the network LSA. Point-to-point, point-to-multipoint, and point-to-multipoint non-broadcast do not use a DR. Why not? What's the difference between these two? Well, the difference between these two is it is assumed that, especially point-to-point, you got R1 and you got R2. Point-to-point, right? This is a point-to-point connection. There's only 2 devices on the link, so therefore there's no reason for me to try to figure out who's going to be the designated router. For point-to-multipoint would be very similar to this, and we're going to demo out point-to-multipoint because it's a network type. So this will get into play when we start talking about things like DMVPN and how you can communicate back and forth, phase 1, phase 2, phase 3, stuff like that. So when you see a point-to-multipoint, when we go to configure it, it'll be interesting to get down to brass tacks. But essentially when you're doing that, you're not going to use a DR-BDR because you're going to assume whoever the point-to-point connection. So essentially what will end up happening is this guy right here will be point-to-multipoint. These guys will be all point-to-point. And why will they be point-to-point? Is because they're all going to be pointing back to the hub, not to each other. So if you want to do a scenario where you've got a central point in the network, R1, then typically this is going to be seen more in like frame relay environments, but MPLS VPNs, that type of stuff, when you're trying to route over it and not route through it. When you have scenarios like this with overlays, you're going to run into scenarios like this. R1 is acting as the hub, so the hub is going to have access to all of the spokes, but the spokes may not need to have access to each other. And you want to have communication back to the hub. You would set R1 as point-to-multipoint, so it's going to have multiple endpoints connecting to it, but the spokes would be point-to-point, pointing back to R1. So in those particular cases, you don't need a DR, right? Because you don't need to. You're going to be forming an adjacency with one specific device. That's the whole point here. It's going to be one specific device. Now, when we do that, we have broadcast and NVMe use a timer of 10-second hello, 40-second interval, and then point-to-multipoint, point-to-point, point-to-multipoint, and point-to-multipoint non-broadcast use 30-second hello and 120-second dead. So anything, this right here is always going to be 4 times the hello. Simple as that. So keep that in the back of your mind. And then you have MTU issues. By default, OSPF uses 1500. So in the case where 1500 is there, if the other side is 9000, right, that does not equal. So therefore, you will have MTU issues. The OSPF adjacency will still form. It'll still do its thing. It'll still form. But the moment this guy tries to send an update outbound and it clogs this guy's arteries, and OSPF freaks out and goes, hold on a minute, guys, I can't handle this, OSPF will then fail. The idea is you want to have the same MTU on both sides. Now, what's interesting is you can do the MTU ignore command to say, I don't care about the MTU, but as it's going back and forth and checking on it, it's going to trigger. And again, it's one of those things where it should get to the neighbor portion, but you won't form a full, it won't do a database exchange, because once it gets down to doing the MTU check, I believe it'll still it'll form a neighbor, right? It'll form the neighbor, but the database won't go through. So that's just a thing to keep in the back of your mind. We'll double check on that one, because MTU issues don't normally occur. Even though I just talked about one for like 5 minutes straight, where I talked about EIGRP, but that's a different story. EIGRP, the neighbor adjacency will form. However, when you go back and forth and do route exchange, that's when you're going to get the round trip timeout of 5,000, which basically is max age. So we'll talk more about that in detail later, but I wanted to go over just a quick high level what happens when you're troubleshooting OSPF. This is some of the things to keep in the back of your mind in terms of the high level overview. So we're going to dive more into this when we get into, once we've covered the entire protocol and we're really solid on that, then we're going to circle back and have a bunch of different videos covering different troubleshooting scenarios and stuff like that. So if you guys are interested in that type of stuff, stay tuned because that will be coming. With that being said, ladies and gentlemen, that is all I have for you when it comes to troubleshooting OSPF. If you have any questions, comments, concerns, feedback, drop that sucker in the comment section below. If you haven't already done so, please like, share, and subscribe, and I'll catch all of you fine people in the next video.